over questions under logarithm and indices, and also set theory. So in my last video, we have looked at several questions under logarithm and indices, and also an aspect of set theory. Now today we are going to look at some questions based on what we have learned before and new concepts. All right, so before we start, I will want you to invite your friends and let them know that the class has started. So get your writing materials available. We are going to be making use of our logarithm tables. So make sure you get your 4-figure tables, okay? And also your writing materials. And don't also forget to subscribe to this channel if you have not subscribed, so that anytime you're online or live, you'll be notified. All right, so I want to believe everybody is set now. Now let me check those people that are online. All right, we just have one person. Please invite your friend. Share this video with your friends. You can share it with your friends in the class. Okay, they're in the same class, so share this video with your friends. Okay, now let us start. Let's look at the question we have on the board. This question is under set theory. The question is under set theory. Let's look at it. Let U be the set of 1, 2, 3 down to 10. Sorry, it's a finite set. Now, U to be the set of 1, 2, 3 down to 10, be the universal set. And A is the set of prime numbers. B is multiples of 2. C is the set of x such that minus 2 is less than x less than or equals to 8, where x is a natural number, and D is the set of x such that x is less than 5 and x is also a natural number. Now, we are required to list members of set A, B, C, and D. So that's the first task to do. Now, let's begin to list members of these sets. Now, the first one, which is set A. All right, I want to believe everybody is around. Okay, I'm seeing like 4 viewers here. So please don't forget to invite your friends. Let them know the class have started. All right. Now let's look at the first set. We have A being the set of prime numbers. Set of prime numbers. So now the question I ask myself is this: what are prime numbers? Prime numbers are natural numbers that have only 2 distinct divisors. Okay, only 2 distinct divisors. So they are 2, 3, 5, 7. Okay, now the next one should be 11, but you must not list anything outside the universal set. I said that in the last class. All sets under consideration are subsets of the universal set. So we are stopping here. Okay, now let's look at the second set. Now, set of multiples of 2. Multiples of 2. Now, the list among multiples of 2 is 2. Now, followed by 4, followed by 6, followed by 8, followed by 10. So I'm going to stop here because of our universal set. All of these must be a subset of the universal set. Okay, now the next one we have, okay, this is a set builder notation. So we have set of x such that minus 2 is less than or equals to x and x is less than or equals to 8, where x is what? A natural number. So n represents set of natural numbers. So All right, so if you are listing all these elements now, so you have minus 1 is 0, 1, 2, 3, 4, 5, 6, 7, and 8. But when you look at this, a condition has been given that you are expected to list only natural numbers. And don't forget, natural numbers are what? They are counting numbers. So that means this will not be inclusive. This will not be inclusive. So the set of numbers you will be listing now will now be 1 down to 8. So we now have set of 1, 2, 3, 4, 5, 6, 7, 8. Okay. All right. Now let's move to the next set. That is set D. Now set D is the set of x such that x is less than 5. Set of x such that x is less than 5. So, and x is the natural number. Now, I must know what natural numbers are. They are what? Counting numbers. Counting numbers are 1, 2, 3, 4, and so on. So, now, natural numbers that are less than 5. So, let's list natural numbers less than 5. We have 1, 2, 3, and 4. All of these are natural numbers. They are counting numbers, and they are also less to 5. Okay, so we have done the first task. All right. Now let us look at the second part of the question. So before we do this, please don't forget to invite your friends, share this video with them, and let them know the class have started. Okay, let me see the number of people available here. So, okay, we still have like 10 of you here. All right. So please share this video with your friends. All right, now. So now the next thing now is to find complement of C. Complement of set C. Now, complement of set C are those members of the universal set but are not in set C. I come again. Complement of set C are those members of the universal set that are not member of what? C. Okay, now can you please tell me complement of set C? Now I want you to begin to drop your answer. Complement of set C with the definition I just gave you now. Can you list complement of set C? I said complement of set C are those elements in the universal set, calling you, but are not in set C. Okay, I'm waiting for your answer. Please drop your answer in the comment section. Complement of set C. Okay, some people have dropped an answer. Okay, let me see. All right, Balogun have dropped an answer. So let's wait for others. Okay, I have an empty set. All right, okay. So now let's look at it. Let's do it together. Now, complements of set C are those elements that are not here, but are inside the universal set. Now look at set C. We have 1, 2, 3, 4, 5, 6, 7, 8. The elements that are not here and are here are 9 and 10. So this is the answer to the first part of the question. Okay, now let's look at the second part. Now we have B intersection C complement. B intersection C complement. B intersection C complement. Now, what are we expected to do here? Now we need members that are in B and are also in C complements. Members that are in B and are also in C complements. Okay, that is B intersection C complement. All right, so can you list those elements? So you'll be having 10 because 10 is here, 10 is also here, so we have 10. So 9 is here, 9 is not here, so you can't Write 9. So it's going to be a unit set of 10. So that is the answer to that question. Now let's look at the third one. Number of elements in B intersection C complement. Number of elements in B intersection C complement. Now look at this. Now you just come to this set and count the number of elements we have inside. So how many do we have? We just have 1. Okay, so the answer to this problem is 1. All right, so now this is the solution to this problem. Now let's see how are we going to award marks to this question. All right, now so there will be a block mark for the correct set. Yeah, B1 to this, B1 to this, B1 to this, B1, B1, and A1. So this is how the mark will be awarded. So how many marks altogether? We have 1, 2, 3, 4, 5, 6, 7. So we have 7 marks altogether. Okay. So let us move down to another question on that set theory. Let A be the set of Okay, now let's look at the next question on the board. We have let A be the set of composite numbers less than 6. Composite number less than 6. Now find all subsets of set A. Find all subsets of set A. Now the first thing now is to list members of set A. Okay, before you now find all subsets. So now let's list all subsets of set A. So I want you to tell me what are the members of set A. Okay, I think you should be able to do this now if you attended the last class. So we explain what composite numbers are. So now you have to list composite number less than 3. Now let's wait for your answers. All right, so composite numbers less than 6. Composite number, drop your answer. Let me see. Composite numbers less than 6. Okay. Composite numbers less than 6. All right. Is anybody giving me? Okay. Now let's look at it together. Now, composite numbers less than 6. Now, the first thing is to know what composite numbers are. Now, by definition, composite numbers are natural numbers that have more than 2 divisors. They have more than 2 divisors. Okay? So composite numbers are natural numbers that have more than 2 divisors. So now let's begin to look at such number. So the first of them is 4. All right. Now followed by, we're supposed to have 6. But it's unfortunate the only element we have there is just 4. So we have 4. All right. So now what the question wants us to do is to find all subsets of set A. All subsets of set A. All subsets, the first one is an empty set followed by set 4 itself. So this is the answer to that question. That is pretty simple. Okay. So now we are going to move down to another question on the logarithms. Express 63.5 as power of 10. As power of 10. So now let's look at this question. Express 63.5 as power of 10. So how do you do this? Okay, now the first thing now to do here is to express this number in standard form. Now let's express this number in standard form. 63.5 is the same thing as 6.35 times 10 raised to the power of 1. All right, when converting number to standard form, now what we do now is we move the point to the back of the first significant digit. So the first significant digit here is 6. So you move the point. Now we are moving it to the front. Now the number of times we move the point is what we put here, right? So now since we move it once, so that is why we are having 10 raised to the power of 1. All right, now, so the next thing to do is to have 10 raised to the power of 0 point. So you write this, and you now make use of your 4-figure table. You check logarithms of 63 under 5. 63 under 5. Now I want you to check this and drop your answer in the comment section. 63 under 5. Check your logarithm table. So let's see, what do we have? I have my own answer here. So I want you to check your own 4-figure table. I told you to get 4-figure table ready. So it's going to be an interactive class today. So let me see your answers. Okay, I can see someone dropping an answer. We have 8028. Okay, so let's see. Let's wait for others. All right, okay. So now if you check very well, you are going to have 8028. Okay, so those of you that have 8028, you are correct. So that is logarithm of 63 under 5. Okay, so times 10 raised to the power of 1. Okay, now the next thing now is to apply law of indices. So now since the bases are equal, so you add the powers together. So we have 10 raised to the power of 0.8028 plus 1. Okay, so when you add, you have 10 raised to the power of 1.8028. Now this is going to be the answer to that problem. All right, so that's going to be the answer to the problem. So now, how do we award mark? So now for this one, for listing members of set A, you have M1. And for getting all subsets of set A, we have A1, just 2 marks. Now let's look at this. Now you have expressed this number in standard form. There is a method mark for that. That's M1. Okay, and for applying law of indices, adding these powers together, you have M1. And for getting the correct answer, you have A1. So all together we have 5 marks. 5 marks. All right. I want to believe you are learning. All right. So please don't forget to invite your friends. If you observe that your friends are not here, so invite them, send a link to them. All right, now let's move on. Now the next question, use tables to evaluate cube roots of 63.3 times 0.0034 over 11.3 raised to the power of 2. Okay, so that's the question. So you have to evaluate this, making use of your tables. All right, so now let us draw our number log table. So we have number log. Now we have 63.3 times 0.0034. Now we are making use of our four-figure tables. So now make sure you have your four-figure table with you, because you are going to be giving me the answer to this problem. All right, now the first thing is to change all of this number we have here into logarithm. So we are going to evaluate everything in the logarithm side. After solving it, we now change it back to number, making use of our anti-logarithms table. All right, now let's look at this. Let's change this number to logarithm. Now the first thing is to find the characteristic of the number. So characteristic of this number is the number of times you're going to move the point to convert this number to standard form. So now if you have to convert this number to standard form, you will move the point just once, because the point should be at the back of the first significant digit. So that means the characteristic of this number is what? 1. So we have 1. Okay, so now you now check 63 under 3. 63 under 3. So check your logarithm table and tell me what is the answer to this. So I want to have your answer. 63 under 3. So what do you have? 63 under 3. So I have my own answer here. So check 63 under 3. Okay, I'm seeing answers. Okay, good, 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 good. Now I can see 8014. That is correct. 8014. That is what we have in our four-figure table. Okay, so now the next thing, look at the number we have here. So we are going to get the characteristic of this number. Don't forget what I said earlier. Now the characteristic is the number of times we move the point to convert this number to standard form. So we are going to move this point how many times to the back of the first significant digit, which is 3 in this case now. So we'll move it 1, 2, 3. So we are moving it 3 times to the back of our 3. And as you can see, we are moving in direction of negative. So that means the characteristics is going to be bar 3. We have moved it 3 times to the back. Okay, now don't forget, you can see that I'm putting plus here. Now the reason is because we have multiplication here. So whenever you have multiplication, at the logarithm side is going to be addition. I told you why. By definition of logarithms, we said logarithms of a number to a given base is the power to which the base must raise to give that number. So now, in another word, logarithms is also the same thing as index, is the same thing as power. And don't forget, in your law of indices, when you are multiplying numbers, what do you do to the powers? You add, right? So since we are multiplying here, the number, so you add the power. So we are adding the power here. Okay, now let's check our four-figure table. You check 34 under 0. Now drop your answer. Let me see what we have. 34 under 0. So most of us are doing well. You are giving the correct answer. 34 under 0. Okay. Somebody have dropped. Okay. 34 under 0. Okay. I'm seeing 3, 5, 1, 5. Okay. 3, 5, 1, 5. 3, 5, 1, 5. Okay. Okay. All right. Okay. So 3, 5, 3, 5, 1, 5. Now, please don't forget, because I'm seeing different answers there, it is wrong for me to write minus 3.3515. This is wrong. You know why? Because the negative here is affecting this integer 3 and it's also affecting the decimal part. Now, you see, number in logarithm are divided into two parts. We have the integer and the mantissa. The mantissa is always positive. So if you write negative at the front of this number now, it's affecting this 3 and it's also affecting what we have here. So that will not be correct. So that is more reason why negative is always written at the top. All right, you get that now. So you cannot write the negative at the front this way. So please, let's take note of that. So now this is what we are supposed to have. So now let's add these numbers together. Now 4 plus 5, we have 9. 1 plus 1, we have 2. 0 plus 5, we have 5. 8 plus 3, we have 11. So you are writing 1. So that one added to this, you have 2. 2 plus bar 3. Now bar 3 is the same thing as minus 3. So you just have minus 3 plus 2. Minus 3 plus 2 is the same thing as what? Minus 1. So, and don't forget, I can't write minus 1 here. So I'm going to have bar 1. Hope you get that. All right, so we have bar 1. Now, this is for the numerator. Now let's look at the denominator. So we have 11.3 raised to the power of 2. Now, the first thing to do here as well is to write the characteristics. So this is, let's put it here, this numerator. Okay, now for the denominator now. So now, the characteristic of this number is what? 1. I'll move the point just once. So we have 1 point. Okay, so now you check 11 under 3. 11 under 3. What do you have? 11 under 3. 11 under 3. So let me see what you have. 11 under 3. 11 3. 11 under 3. Okay, what is 11 under 3? Okay, 11 under 3. Okay, so if you check very well, 11 under 3 will give you what? 11 under 3, if you check very well, you are going to be having 0, 5, 0, 5, 3, 1. 0, 5, 3, 1. Okay. Yes, I can see that a lot of us are following the class. So I think there is a mix-up here. So now I think this is supposed to be 5, 3. That is what we have. 5, 3. I'm trying to cross-check with what I have here. It's 5, 3. Okay, so that means we need to adjust our answer here. So sorry for that mix-up. Now let's do it again. So when you add this and this together, you have 9. This will give you 1 plus 1, we have 2. Now 0 plus 3, we have 3. Okay, so now when you add 8 and 5 together, what do you have? You have 13, so you have 3. Okay, so you have 3. So you have 1. So add down 1 to this. That's 2. 2 plus minus 3, that gives you 1. I think this is now better. Okay, so this is the value for the numerator. All right, now, so here, now we have checked 11 under 3. So now you have a power of 2. So the next thing is to multiply what we have here by 2. So now let's multiply it by 2. Multiply by 2, what do you have? So 2 times 1, we have 1. 2 times 3, that is 6. 2 times 5, that is what? That's 10. So you write 0. You keep 1. 2 times 0 is 0 plus that 1, you have 1. And the 2 times 1, that is 2. Okay, so that means when you multiply this by this is what you have. All right, so this is what we have for the denominator. So now we are going to subtract. So let's extract this out. So the numerator is 1.3329. While the denominator, so will be minus 2.1061. Okay. So now that is what we have. So we are going to subtract. You know why we are subtracting? We are dividing. We are dividing this by this. And when dividing, what do you do to the power in indices? Now you are going to subtract. So now let us subtract and see what we have. Okay, so all right. So I think this one's supposed to be 2. That's the fourth one. Okay, so now let's adjust these two. So when you add this and this, you have 11. Okay, so that's 11. So you write 1, you keep 1. So let's add 2 and 6 together. That is what? That's 8. Plus that 1, that gives you 9. So when you add this and this, you have 3. 3 plus 1, that is 4. Okay, so I think there's a mix-up. We are supposed to be subtracting. Oh, sorry for that. We are supposed to be subtracting. Sorry for the mix-up. We are supposed to be subtracting because we have a sign of subtraction here. So you have 9 minus 2, that's 7. Okay, so we have to get 1 from here, that's 12. 12 minus 6, we have 6. So we are left with what here? 2. So 2 minus 0, you have 2. Okay, so now we have 2. 2 minus 1, that is 2. Okay, so now we have 1 minus 2. So 1 minus 2, that gives you minus 1. I told you earlier that you cannot write minus 1. So you have bar 1. All right, so that is what we have. So now, the next thing is, you can see what we have here. We have cube root of 3. Cube root of 3. So we are going to divide our answer by 3. So now let's divide by 3. Let's divide by 3 and we'll write the answer here. So when you divide by 3, now so 3 goes in bar 1. You will see that it will not work. So you have to move out here. So let's see what is going on here. So what do we have as answer here? So we have this. Okay, are we sure? Now this one's supposed to be, now please, now let's be careful with this. We have to handle it with care so that we don't mix everything up. So now I want us to go through what we have here again. So we have 4 plus 5, we have what? We have 9. 1 plus 1, we have 2, right? 0 plus 3, we have 3. 8 plus 5, what do you have? You have 13. So you write 1. So now you add down 1 to this. So it's going to give you 2. 2 plus minus 3, that gives you minus 1. So what we are supposed to have here should be bar 1. Okay, that should be bar 1. All right. So sometimes you have to be careful when solving problem. So you have to go through what you are doing so that you will not end up getting the wrong answer. Okay. So now this is what we're supposed to have. So this must have bar 1. All right. So now let us now look at the subtraction now. So we have 9 minus 2, you have 7. You have to borrow 1 from this 3. That's 12 minus 6. We have 6. We are left with 2. 2 minus 0, we have 2. 3 minus 1, we have 2. Now we now have minus 1 minus 2. Bar 1 minus 2 is the same thing as minus 1 minus 2. So we have minus 3. Okay, so what we have here now is bar 3. So you will not write minus 3, you just have bar 3. So we can easily divide now. Okay, so now let's look at it now. 3 goes in bar 3. That's going to give you bar 1. Okay, and 3 goes in 2 is 0. So you write 0 because you are not going to have an answer for that. So you pick 2 digits together now. 3 goes in 22. That gives you 7. You have a remainder of 1. So that 1, you put it in front of this 6. That gives you 16. So 3 goes in 16. That is 5. You have a remainder of 1. So you put the remainder here. All right, that is 17. So 3 goes in 17. That will give you 5. You have a remainder of 2. Okay, so you put 0 at the back of the 2. Now 3 goes in 20. That's going to give you 6. But we just want our 4 DP. So we have 1, 2, 3, 4. So now we are going to throw this away, but because this is up to 5, you can turn it to 1 and add it to the next digit. So what we are going to be having now is going to be bar 1.0756. Okay, so now let's change this now to number, making use of our anti-logarithms table. So you check point 07 under 5 and add difference 6. 0.07 under 5 difference 6. So now let's check that and let's drop our answer. Okay, so we are making use of your anti-logarithm table here. Okay, so now let's do that. Okay, let's see what we have for that. Yes. What do we have? Okay. I can see 1193. Okay, let's wait for others. 1193. Okay. Your anti-logarithm table, check 07 under 5 and add difference 6. Add difference 6. So, okay. I can see only one person dropping an answer. So let's wait for others. All right. Balogun have dropped an answer. So 1191. 1191. Okay. All right. So 1191 is the correct answer. 1191 is the correct answer. Okay. So now we'll not just leave this here. You can see that we didn't touch this integer. All right. So that's bar 1. So now you just write 10 at the front of this value you have here. So you have 0 and you put your points. So if you have bar 2, you will be putting 2 zeros at the front of your values and you put point at the back of the first zeros. Okay, the first 0. So if we have bar 3, how many zeros are we going to put here? It's going to be 3. So and you put point at the back of the first 0. All right, so since we have only bar 1 here, so you are just writing 10, put point at the back of the 0. So this is going to be the answer to this problem. You can see we have changed it back to number. So now when you evaluate this, this is what we have. All right, so now how do we award mark to this question. All right. Now, the first thing is for checking all of these correctly, we have B1 for this. That's block mark. So B1 for this. Okay. Now, for checking this also correctly, we have B1. Okay. So now for multiplying by 2, there's a method mark for that. All right. Here, for subtracting, we have subtracted because we are dividing. So there will be a method mark 1 for that. And for getting this answer we have here, A1, and getting the final answer, another A1. So now what is the total mark for this question? Let's count. 1, 2, 3, 4, 5, 6, 7. So we have 7 marks all together. All right. Okay. Now, before we move to the next question I have here, which is going to be under indices, please, I want you to subscribe if you have not subscribed to this channel, so that you will always be notified whenever the class starts. And don't forget that you need to invite your friends. So if you observe that your friends are not online, just send a message to them and let them know the class has started. All right, now let's move to the next question. Let's move to the next question under indices. Okay, we have, if 2 raised to the power of 1 minus x times 2 raised to the power of x minus 1 over 2 raised to the power of x plus 2 equals to 8 raised to the power of 2 minus 3x. Find x. Okay, so this is the question. So this question is under indices. It's under indices. So how do we solve this problem? Solution. We have 2 raised to the power of 1 minus x times 2 raised to the power of x minus 1 over 2 raised to the power of x plus 2 equals to 8 raised to the power of 2 minus 3x. Now the first thing is to apply law of indices here. You can see, look at the numerator. Now you can apply the first law of indices. Once you are multiplying and you observe that the base is the same thing, so you add the powers together. So that means the numerator turns to 2 raised to the power of 1 minus x plus x minus 1. Hope you get that. You add this and this together. So this is the first term, this is the second one, so you add together. Divided by 2 raised to the power of x plus 2 equals to, now you can express this in index form. This is 2 raised to the power of 3. So 8 is the same thing as 2 raised to the power of 3. So, and we have 2 minus 3x. Okay, so now the next thing is to cross multiply. You cross multiply. Now let's use this to multiply this. So we have 2 raised to the power of x plus 2 times 2 raised to the power of 9. I can open this bracket to have 6 minus 9x. 3 times 2 is 6. 3 times minus 3x is minus 9x equals to 2 raised to the power of 1 minus x plus x minus 1. All right. Now, when you look at this equation carefully, you can see apply law of indices here. The bases are the same thing. You can add the powers. So now this left hand side turns to 2 raised to the power of x plus 2 plus 6 minus 9x equals to 2 raised to the power of, now let's tidy this one up, minus x plus x. So this one cancel this, all right, plus 1 minus 1. So it cancel out. So everything here turns to 0. Okay, so now what do we have next? Now let's tidy up the power here. So we have 2 raised to the power of, now this is x and this is minus 9x. So that is going to give us minus 8x. All right, so we have minus 8x. Now look at this. When you add this and this together, it's going to give you plus 8. 2 plus 6 is 8 equals to 2 raised to the power of 0. Okay, so now here, the base is the same thing. You can equate the powers. Right, so we have minus 8x plus 8 equals to 0. So let's move this one to this side. We have minus 8x equals to minus 8. Don't forget the sign will change. So now here you divide both sides by minus 8. So you have x equals to minus 8 over minus 8. So therefore, x equals to what? 1. So that is the answer to the problem. All right, so how do we award marks to this question? Now, for expressing this in this form, now you have applied law of indices here and also here. So you have applied law of indices. You've turned this 8, the 8 we have here, you've turned it to 2 raised to the power of 3. So there will be a method mark for that, M1. Okay, now for applying law of indices here again, coming to this level, there's another method mark for that, M1. All right. Now, for also equating minus x plus 8 equals to minus 8x plus 8 equals to 0, there will be a method mark 1 for that. And for getting your answer, an accuracy mark 1. So altogether, we have 4 marks. 4 marks. So that is the solution to that problem. Okay, so now let's move down to another nice question under indices. Okay, so we have solve 5y equals to 40 y raised to the power of minus 1 over 2. All right, so this is the question. So how do we solve this problem? Now, you can see that we have y in both sides of the equation. So now let's write the question. 5y equals to 40y minus 1 over 2. Now, the first thing is to divide both sides by 5. Let's divide both sides by 5. So we have 5y over 5 equals to 40y raised to the power of minus 1 over 2 over 5. So when you do that, 5 cancel 5, we have y equals to, now 5 goes here 1, 5 goes here, what, 8. So we have 8 y raised to the power of minus 1 over 2. Hope you get that. All right, now, so the next thing here is to divide both sides by y raised to the power of minus 1 over 2. Because now I want these 8 to be standing alone. All right, so now to make this 8 stand alone, so I have to get rid of this. So I'll divide both sides by this. So that means this one comes under this place. So we have y divided by y raised to the power of minus 1 over 2 equals to 8y raised to the power of minus 1 over 2 over y raised to the power of minus 1 over 2. Hope you can see that. So now this cancels this. So now you can join these together. I'll be applying law of indices here. When dividing and you observe that they have the same base, okay, now you subtract the powers. So you have y equals to 1 minus 1 over 2. Hope you get that. Now you are dividing this by this. They have the same base. You subtract the powers. So you have 1 minus 1 over 2. Okay, so, and this, you are left with 8 here. All right, so Okay, all right. I think I'm now on now. Okay, so now I said we should try this problem. Try this problem and drop your answer in the comment section. And let everybody try this problem. Okay, I think Balogo can hear me now, because I can see that. Okay. Okay. Once you are done, you can drop your answer in the comment section. Make sure you are doing it. Try the problem and make sure that you drop your answer in the comment section. Okay, someone have dropped an answer. Bamidele have dropped an answer. Okay, that's 4. Okay, let's wait for others. Let's wait for others. Okay, because of our time, it's just only one person that I'm seeing his answer. So now let's do it together. Now to solve this, the first thing is to divide both sides by 2. So you have x raised to the power of minus 3 equals to minus 16 over 2. Okay, so now you have x raised to the power of minus 3 equals to, when you divide this by 2, you have minus 8. Okay, so the next thing is to multiply the power here and the power here by the reciprocal of minus 3. The reciprocal of minus 3 is minus 1 over 3. Okay, so now let's do that. We have x raised to the power of minus 3 times minus 1 over 3 equals to minus 8 raised to the power of minus 1 over 3. Hope you get that. So is another word. In another word, we are saying that we are taking cube root of both sides. All right. So now minus times minus, that is plus. Now 3 cancel 3. So we have x equals to. Now this is going to be the cube root of minus 8 raised to the power of minus 1. Now these 3 have turned to the cube root here. Okay, so we have x equals to, now when you find cube root of minus 8, you have minus 2. You have minus 2 raised to the power of minus 1. Okay, so therefore x equals to 1 over minus 2. So this is going to be the answer to the problem. All right, so how do we award marks to this question? Now, for dividing both sides by 2 and having this, we have M1. We have M1. Okay, we have M1 for that. And for simplifying it down until we get to this level, we have another M1. And for getting the answer, we have A1. So 3 marks are question. All right, so I want to believe we have all learned one or two things today. So I want you to continue now with this at home. Look into your textbook, whatever textbook you are using in your respective schools. Now solve similar questions that look like this, and you will see that after some time you begin to have confidence in mathematics. So thank you very much for watching. Bye bye.